So we are looking at geometric means, and recall that we use geometric means to average percentage changes. Right? And in the last video, we saw, well, what are percentage changes? How do we average them when we have a couple of them in an example, right? Where that radical is just a square root. But what happens if we have more than two percentage changes that we want to average and we need to use a geometric mean? And that's where that funny little n comes in here. So what does this mean? It's called an nth root, but what exactly does an nth root mean? Well, let's take a look and see what it means and look at a few examples. So the basic idea is that if x is an nth root of some number b, that means if we raise x to the nth power, we get b. If the n isn't there in that symbol, it means it's a square root, right? So for example, the square root of 9 is 3 because 3 squared is 9. 3 times 3 is 9. 3 to the second power is 9. So here's a few more examples. Since 7 to the fifth is 16,807, that means the fifth root of 16,807 must be 7. Since 2 to the 11th is 2,048, it means that the 11th root of 2,048 is 2. And now if I don't specify the n, but I just say I know 4 to the n equals 262,144, that means that the nth root, whatever n may be, of 262,144 is the number 4. So how might you find these on your calculator if you're doing a hand calculation? Well, it actually comes from exponents. You can express an nth root in terms of an exponent. Now you might have a calculator that can do an nth root, and that's great. But if not, whatever n is, take its reciprocal and use that as an exponent. So here's a short example. If we wanted to find the third root of 143, we rewrite that as 143 to the 1/3 power. That you can put into your calculator, and if you put into your calculator, you get 5.23. Pause the video and take a moment to verify that. Okay, hopefully you verified it. The little squiggly equals means approximately because I rounded to 2 decimal places. So how does this help us calculate geometric means? So we know that the answer when we get a geometric mean has to do with one of these nth roots. So where n is the number of percentage changes we're averaging. So let's look at an example where n is 3. So here's our second example. Remember that we're using return on investment. That's the percentage change in an investment over the course of a period of time. So if our first month, from the beginning to the end, our ROI is 3.24%, then our second month is negative 1.61%, and now in our third month, our ROI is 5.03%. We're going to find the average. In the previous video, we averaged the first two. Now we're going to average all three. So recall what that means is first, we have to add 1 to each, where we treat each as a decimal. We multiply them together and then take a third root. So here's what that looks like. The 1.0324 is 1 plus 3.24%, with 3.24% written as a decimal, 0.0324. The 0.9839, well, that comes from adding 1 to the negative 1.61%. Recall we write that as a decimal, negative 0.0161, and subtract that from 1. We get 0.9839. And then for the positive 5.03%, write it as a decimal, 1.0503, and then you add 1. Take these three numbers, multiply them all together. That's what's under the radical. And then you take a third root. And recall that that's the same as taking a power of 1/3. And the answer we get when we do that is 1.0218. Before going on, pause this video and perform that calculation and make sure you get the same thing. So hopefully you verified that. And remember, we subtract 1 off from that result to get our average percentage change. So if we take the 1 off, our average percentage change is 0.0218, or in percentage terms, 2.18%. So the 5.03% helped us increase our average after it was brought down by the losses in the second month. So this is what this means. This is how it's done by hand. But let's move back to the 21st century. And in the next video, we're going to do a more involved example, but all the calculations will be done by Excel. So I'll show you how to do that.